The design of no-mask anodes begins with the part being plated. That's because each anode is custom designed to hold and plate specific parts.
This particular part is a sample part that we use to help demonstrate the no-mask technology. It's very similar to a wing flap actuator found on, for example, a 737 aircraft. And as you can see, we've taken a portion of the no-mask anode and removed it so that you can see how the anode itself is constructed. This example no-mask anode provides a good way to look at some of the design aspects of the technology. And I'll start by taking it apart. For this particular part, we're plating two different journals. There's a lower journal here and an upper journal right there. The no-mask anode is designed with a built-in conforming lead anode, and that's built into a PVC housing. The housing creates a mini plating cell. It isolates the plating activity within this cavity. Therefore, the anode is not going to electrically communicate with any other part of the part being plated, and no additional masking is necessary. The lead anodes are electrically connected to the rack through a waterproof and chemically resistant cable. The PVC housing has holes both on the top and on the bottom. The upper holes allow the electrolytic gases that are created during the plating process to escape. The bottom holes allow solution, fresh chrome solution, to flow into the plating cavity. And as the gases escape, they're creating a siphoning effect and pulling fresh solution into that cavity on a very steady basis. The bottom holes on the fixture are aimed so that that fresh solution is being pushed right against the area being plated. And this significantly increases the plating rate. A small spacer is added to separate the two anodes and to make sure that they are centered properly. The upper anode is attached. And as you can see, in this case, there are no tools that are needed to put this together. And there it is, ready for plating.
This video will demonstrate the prep and plating of the horizontal pin, or H-pin, for a CH-47 Chinook helicopter. The H-pin has leading and trailing edges with two journals between a central window. The journals, and nothing else, are what need to be chrome plated. With previous hard chrome tooling methods, this meant hours of masking with tape and wax, overplating to ensure thickness, more hours of removing the mask, then machining the chrome down to uniformity. Not anymore. With innovative hard chrome tooling, the process is easy. The first step is to prepare the H-pin for plating by degreasing and cleaning it with an aluminum oxide blast. Then the technician should inspect the part for damage and match the part serial number to the traveler. We can use 1-inch vinyl tape to provide a nice straight plating edge above and below the window cutout. Start by winding tape around the pin at the edge of each window. This will prevent chromium from being deposited too close to it. Then use 2-inch tape to cover the window itself and secure the edging tape. And that's it. The part is ready for plating. No more lead tapes, no more wax, no more hours of unmasking and machining. Because no-mask anodes are custom made on a part-by-part basis, there are some design aspects that must be considered. The no-mask anode system for the H-pin consists of a rack that holds and plates 2 pins simultaneously. Each H-pin has 2 sets of anodes, one for each surface being plated. With the no-mask approach, the anode and surface to be plated are enclosed, and electrolytic activity and chrome deposition are restricted to the area within that enclosure. The remainder of the part can be wetted by chromic acid, but there will not be any chrome deposited on it, because those surfaces lie beyond the electrical barrier. The enclosure is made of machined PVC. The lead anode, which is shaped to conform to the geometry of the part, is attached inside the enclosure, and its matching shape will ensure even deposition. The waffle configuration of the anode increases its surface area and improves solution circulation within the enclosure. A waterproof copper cable is welded to the lead anode. This cable carries electricity from the upper bar rack to the anode, which carries a positive charge. The part being plated is connected to the bottom bar of the rack and receives a negative charge during plating. The distance between the conformal anode and the surface being plated is typically less than 1 inch, compared to 6 to 12 inches commonly used with stick anode plating. This method significantly improves speed and efficiency. Typically, no-mask plating is 2 to 3 times faster than stick plating.
Today we're going to be chrome plating the hinge pin. This is a high-strength steel alloy pin. It gets chrome plated in 2 locations, here and here, very precise locations. In the old days, they have to tape and mask. This new system is the no-mask anode plating system. We call it a whole system plating system. We're going to load the piece as such. These parts are, of course, prepared by grit blasting. We load them into the fixture. It's a simple process to locate them. The tools are self-locating. We're going to isolate the plating between 2 cells. Part number 2, load it in here. All right, part number 2 will be loaded as such. Same as part number 1, good connection. We wiggle it around to make sure we're seated well. We've got good conforming contact areas. The current is fed through the rack frame as such up to the bottom of the cathode. We're going to now install the upper anodes, the little spacers that we'll put in here. These do nothing other than to shield the part from any stray current. We'll bring the anodes in. These are the upper anodes. It's a simple installation. Self-aligning. Put the first one on. We'll put the second one on. Making sure they're seated properly. A couple of washers. Some 3/4 hex nuts. This whole operation should take no more than 5-10 minutes. 10 minutes if you're slow, 5 minutes if you're faster. There's a 1 1/8 crescent, or rather a box wrench that snug them down. Just tight enough so that we connect, make good contact. The tools aren't moving around on us. Flash covers will keep any stray chrome deposits from getting on top of our threads or our hex nuts. This thing is ready to go in the plating tank.
During the plating process, hydrogen gas is generated at the cathode, and oxygen gas is generated at the anode. To allow these gases to escape, holes are drilled into the top of the PVC enclosure. As the gases exit the enclosure, they cause fresh chrome solution to be drawn into the plating cell through these holes. The holes are angled to force the fresh solution across the face of the plated surface. This ensures that there is constantly a fresh supply of chromium ions for the plating process exactly where they're needed. When the H-pins come out, all the technician needs to do is take them out of the anodes and remove the vinyl tape. There's no more laborious unmasking. In some circumstances, machining of the chrome is required. However, it's considerably less wasteful and less time-consuming than the chrome machining associated with traditional plating practices. As you can see, the process is considerably easier and safer than traditional chromium plating. It also results in fewer rejects and less impact on the environment, saving time and money for the Department of Defense. With those savings already in the millions, and the constant need for fast, safe, efficient chromium plating, we can be certain that innovative hard chrome tooling such as the no-mask plating process will be in use at depots for years to come.